This video is about the flow direction of electric current. You will learn here that there are two different definitions for the direction of current flow. One is called physical direction, the other is called technical direction. And we will look at some historical experiments made by a very famous physicist called Ampere, which have led to a wrong understanding of charge movement, which has now been corrected, and the corrected version, which describes the movement of electrons, is called physical current direction. And I will tell you which definition to use in which circumstances and what the difference between the two is. My name is Andreas from The Fearless Engineer, and here we go. You will surely have heard about that in electrical engineering we have a difference between the technical and the physical direction of current. And the question might arise, why do we need two directions of current in the first place? Isn't one enough? And in case we have two, which one is the right one? Which one is the correct one? And this question is absolutely justified, and the fact that we have two questions actually causes a great deal of confusion with many students. Now let's look back in time why we have these two definitions in the first place. Now this concept of electric current as we know it today, the motion, the movement of charges per time, was first introduced by André-Marie Ampère, a very famous French physicist in the 18th, 19th century. And he conducted a large deal of experiments involving electricity, and one of his works involved this Hoffmann water decomposition apparatus, which you can see on the right hand side here, whose job was to separate water, H2O, into oxygen and hydrogen when a power source is connected to this apparatus. The power source can be seen here. It has a positive and a negative terminal, and the H2O is here in the middle, and the electricity causes a separation into O2 on the left side and H2 on the right side. And randomly, Ampère determined that the direction of current flow in this apparatus was from the oxygen wire to the hydrogen wire. So from the oxygen anode to the hydrogen cathode. And this is why we have this notion of the direction of electric current from the positive to the negative terminal, because Ampère chose by random that the motion should occur between, or should be counted from oxygen to hydrogen side of this particular apparatus here. And today we know that in this experiment with the Hoffmann water separation apparatus, the electrons are moving, not the protons. The negative charges are moving, not the positive charges, which is totally contrary to Ampère's definition, which stated that the charges were moving from anode to cathode, but it's vice versa. Charges are moving from the negative to the positive terminal, which is from the cathode to the anode. And in order not to create a conflict with the already existing literature, who has been written in decades and even centuries in some cases, two directions of current were introduced in order to mitigate this problem, which were then called the technical and the physical direction. The technical direction is the one introduced by Ampère in a random fashion. This is Ampère's point of view from the positive to the negative terminal. And the physical direction, this actually describes the motion of the electrons, which is both are depicted here in this small circuit here. We have a battery which has a positive terminal and a negative terminal, and the electrons, they are moving from the negative terminal, which has the surplus of electrons, towards the positive terminal. And this circle here is a conductor, and you can see that within the conductor the electrons are moving from left to right in the physical current direction. Now, Ampère's view is exactly into the opposite direction. The current flow, the technical current direction, occurs from positive against the direction of the electrons moving towards the negative terminal of the battery. This is the difference between these two directions of current flow. If we look at circuit diagrams and in many other applications, the technical current direction is the one we need to assume, unless it's otherwise stated. So our mode of working in almost all applications is to assume a technical current direction from plus to minus. And this often leads to misunderstandings in practice, because the current counting arrows in circuits, they point from plus to minus. So if we see an arrow indicating the flow of current in a schematic, for example, it always is meant to occur from the higher terminal to the lower terminal, from plus to minus. But the electrons, they flow from minus to plus, which is of interest if we are also talking about the magnetic field caused by the electrons. Then we have to take account of the motion of the electrons electrons and not the motion of the current, and this sometimes causes confusion all over the place. So remember that in the circuit diagram we need to use the flow from plus to minus, and in a physical context, for example, when we look at the magnetic field created by flowing charges, then we need to respect the physical current direction. There are some cases when we have a current flow with a negative sign somewhere in a circuit, and if we see something like, for example, the current through a conductor is minus 2 amps, this means that the current is flowing into the direction of the physical current direction. A current with a negative sign is directed in the direction of the physical current direction. And the conclusion, as we can say so far, is that unfortunately we can't avoid this. In electronics we have to deal with two directions of current, and we need to decide, depending on the application which is at hand, which direction corresponds to the applicable conventions. So if we read a schematic, if we design a circuit, we need to use the technical current direction. If we are talking about the effects of electrons moving through space, for example in the context of magnetic field or induction, we need to respect the physical current direction. That's basically all there is to know about these two directions of current. I hope this has become a bit more clear. If you have any questions, please feel free to drop me a comment in the comment section down below. And also, if you like the video, leave a thumbs up and think about subscribing to my channel if you like. I wish you a nice day. See you here next time on The Fearless Engineer.